In class, we talked about how to divide polynomials by using our graphs. And in this lesson, I want to look at using polynomial division. So to explain this process, in example 1, I want to go back to dividing 5 into 85. Show that 5 is a factor of this number. And ultimately what that means is you can take 85, remove 5, and then some amount is going to be left over. Here's what the algorithm looks like. You take 5, write this division symbol, and put 85 underneath it. And we ask ourselves, okay, starting with just this 8, how many times does 5 go into 8? And the answer is 1, so I'll put a 1 above the 8, trying to get as close as possible. 1 times 5 is 5, I'll put that right there. And then we have to subtract that. That's up to us to say, okay, I'm taking that away. And when you do, you get 3. To complete this process, you have to use every single place value. So I'm going to bring down this 5 and repeat the process one more time. This time, I want to get as close to 35 as I can by multiplying something to 5. So I have to figure that out. And the answer is going to be 7. This is going to work out perfectly. 7 times 5 is 35. We're matching them up so they're exactly the same. But then, we are subtracting that away to give us an answer of 0. That's our remainder, I should say. So this means if you take 85 and pull 5 out, there's 17 that is left over. So said another way, 5 is a factor of 85 because when we did the division algorithm, our remainder was 0. I want to use this process, but on polynomials. The setup is going to be the same, but the only difference is that we're going to have to use properties of exponents to get to our answer. So what I'm going to do is take x minus 1, put it in place of where this 5 is, take the polynomial, write it under here, and then carefully go through this process. So that is, I'm going to divide x minus 1 into the polynomial 2x cubed minus 5x squared plus x plus 2. And I'm going to take the same approach of, I first look here, and I want to completely cancel this 2x cubed. So I have to ask myself, what do I multiply to x minus 1 to get a 2x cubed? Well, I multiply by 2 and also by x squared to get 2x cubed. I'm going to write that information above the x squareds. So again, it's up to us to figure out what this is. But why this works is 2 times x squared gets multiplied to x, which gives us 2x cubed. But the difference here is you also have to multiply this 2x squared, you have to distribute it to this negative 1, which gives me a negative 2x squared. So up to this point, we just mimicked this process. I chose 1, multiplied it to 5, and I put that number here to subtract it from this 8. So I have to subtract this thing that I put here. I gotta be careful. I'm gonna put parentheses around it and put a subtraction in front of it. 2x cubed minus 2x cubed is 0. I won't write it. Minus 5x squared minus a minus is really plus 2 will give me negative 3x squared. I now bring down the next piece, which is the x, and I continue this process. Okay, I now want to try to cancel a negative 3x squared by multiplying something to x. So this time, the number is going to be negative 3x. The reason this works is negative 3x times x gives me exactly negative 3x squared. But I have to take this negative 3x and multiply it to the negative 1, which gives me positive 3x. And the thing that I put here, I have to be careful. I have to subtract this away. Negative 3x squared, technically plus 3x squared, is 0, so I'm not going to write it. Now I also have x minus 3x, which gives me negative 2x. And I'm almost done. I'm going to bring down this positive 2, and we're at our last spot. we're at the last place value, just like up here. Okay, I now have to put something here to multiply to x minus 1 to get a negative 2x. And that choice must be minus 2. So negative 2 times x gives me negative 2x. And negative 2 times negative 1 is positive 2. The reason this is going to work out perfectly is that when I subtract this, since they're exactly the same, I get a remainder of 0. Negative 2x plus 2x is 0, and 2 minus 2 is also 0. It's a lengthy process, but here's what it tells us. Just like up here, how I divided in 5, I could remove it nicely and there's just a number left over. Here, I'm saying I'm taking this, I'm removing it from this. This is what is left over, making my final answer. I took x minus 1, I factored it out, and I was left with 2x squared minus 3x minus 2. This is why I used the graph as best I could to factor my polynomials, because this is quite a lengthy process. But this does work. This is how you could factor using polynomial division. I would like to try one more example, again starting with just dividing 5 into this number and comparing it to dividing x plus 2 into this polynomial. So again, is 5 a factor of 4,535? If it is, that means you can factor out with the remainder of 0 at the very end. So let's see, 5 goes into 4,535 with a remainder of 0. Well, for starters, I'm going to skip over this first spot and look at the 45, and 5 goes into 45 a total of 9 times. So you get 45, and we're placing this here so we can subtract it away, and it actually gives us 0. When this happens, I'm not really going to write it, I'm just going to bring down the 3. You could write 0 if you want to, but a 0 in front of 3 is the same thing as just saying 3. And 5 can't go into 3. When this happens, all I'm going to do is place a 0 in this spot. So I'll put 0 here and simply bring down the next value, which is a 5. So anytime that you perfectly cancel and there's a 0 here, you're allowed to skip over the next place value to here. Okay, so now how many times does 5 go into 35? I think we came across this already. It goes in 7 times. 7 times 5 is 35. And if you subtract that, you get a remainder of 0. So said another way, if you factor out 5, there is 907 left over. So let's use this idea in example 4. I'm going to first note that I believe there's an error where this should actually be minus 14. But anyway, I want to divide x plus 2 into this polynomial. So the setup is the same. I have x plus 2, and I'm dividing that into x cubed plus 2x squared minus 7x. Really, minus 14 is what I meant. Okay, so to start, I want to cancel the x cubed by multiplying something to x plus 2. And clearly, x squared times x would give me the x cubed that I want. So above the x squares, I'm going to write the x squared that I'm using. That is, x squared times x gives me x cubed. And x squared times 2, what do you know, gives me 2x squared. So when I go to subtract this away, since the two are identical, x cubed minus x cubed is 0, and 2x squared minus 2x squared is also 0. Like we're running into this situation up here. I'm going to skip over this next spot. What I'm going to do is put plus 0x, just as a reference for myself that, okay, I don't need to use this location. I can simply bring down the negative 7x, but at the same time, just bring down the minus 14. So now that we're at our last place, the question is, okay, I want to cancel negative 7x, which means I have to multiply this by negative 7. We get negative 7 times x is our negative 7x. Negative 7 times positive 2 is negative 14. And when I subtract them, because they are identical, this really becomes a plus 7x and a plus 14. I have a remainder of 0. So we just took x plus 2, we factored it out of the polynomial, and what was left over was x squared. I'm actually going to choose to not write the 0x and just put minus 7. There'd be nothing wrong with including the 0x, but I mean, I think this is just a more concise way to express the answer. And that's it for this example.